Welcome to Complexity Made Simple. My name is Paul Allen, and the subject of today's newsletter is confidence intervals. One of those statistical tools that nobody likes or understands. Why do I need to understand confidence intervals? Especially if you're in a manufacturing process. You're a manufacturing manager, you're a team leader, you're an engineer. Why do I need to understand statistics? Why do I need to understand confidence intervals? Well, it goes to the heart of something that's very important about all your data in your company, and it's this. It's something that you need to take on board and internalize, understand and accept. Every number you look at, every statistic you look at is an estimate. I know we tend to think of mathematics, numbers, as being very precise. You should look at them and think, every number I look at is an estimate. And then what is the next sensible question you would ask if you take that on board? Well, what you would ask is, how good an estimate is it? And what confidence intervals essentially do is tell you how good your estimate is. So, how would this work? Well, essentially, you have a process. The process has produced some items. There we have a bucket of items. What we would like to understand is a distribution, clearly in the bucket. We're going to sample from that distribution in a moment. We want to understand it, and one of the things that we want to understand is the signal. We want to understand the average, the mean. We like to know, typically, if we've hit the target, or we're somewhere close to the target. So we're going to sample. Now obviously when we sample, we create an estimate. So we are going to sample out of this bucket. By the way, even if the bucket isn't made, but your machine is producing, essentially what it's doing is it's producing this bucket. So even if you're taking parts off the machine as the machine is running, you are still sampling from this distribution which is being created in real time, and you are still trying to estimate exactly what is going on. So we're not going to measure all of them, we want a sample. It's a more efficient way. It's statistics saving us time and money. So we take a sample. Let's say we don't want to work very hard and we only take a sample of 10. Okay, now obviously what happens, take sample 10 and I'm going to work out the average from the 10. The average from the 10 is clearly an estimate of what's really going on. And now the confidence interval kicks in, because the confidence interval is going to tell you how good your estimate is. So let's think about this. Here's our average. We've worked out our average from a sample. It's landed there. Using the sample size as part of our calculation, what we're going to do is build something called a confidence interval, which is essentially a boundary which goes up and down from the estimate. This is known, by the way, as the point estimate. The point estimate. We build a boundary. And here's the sort of thing that the confidence interval will say. It'll say, well, if it's a 95% confidence interval, we are 95% certain that the true average, this thing here that we really wanted to know, the true average is somewhere inside that boundary. So let's assume that the true average is really there. Our estimate is just to the right of it. We can't know that. We can never know that piece of information unless we sampled everything out of that bucket, which we're never going to do because it costs too much money. We are 95% certain, however, that this true average is somewhere inside that boundary. And of course, the size of these confidence intervals tell you how good an estimate you've got. So for example, if you take a sample size of 10, which is very poor, by the way, it is a very poor estimate of what's going on. Typically what that's going to mean is the confidence intervals are going to be very wide, and it's going to say, I'm 95% certain the true average is in there somewhere. So in other words, the real average could be out here. How good's your estimate? Well, quite honestly, it's bloody awful. Yeah, because you have to have a really big bucket to have any kind of confidence at all that you've captured the true average of the process. And that's what the confidence interval is telling you. How good is the estimate? Now, of course, if you take a good sample size, and this is what it's really linked to, the confidence interval, forget them in a sense. Really what it's telling you is, what sample size should I take? That's why these things are important, not to work out the confidence interval. Because what we don't want you to do, we don't want you to go at it half-arsed, take the wrong sample size, get a bloody awful confidence interval, and have a terrible estimate. What would be a much more sensible thing to do is this, is to say, okay, look, I would actually like my confidence interval to be nice and tight. I'd like it to be nice and close here, so that the possibility of where the true estimate is very close to the estimate that I actually see. Now, in order to get that nice tight confidence interval, what you really do is this. You specify this width in the maths, and you use that width to calculate a sensible sample size. And that's really how confidence intervals should be used. They shouldn't be used after the fact to tell you that you've been an idiot and you didn't collect enough data. What they should be used to do is to be more intelligent and say, hang on, I want a great estimate of what's going on here, therefore I'll specify the confidence interval I would like, and I'll calculate an intelligent, accurate and useful estimate. And of course, that tells you the sample size. Now, where does that typically come out? Well, if you're measuring variable data, it nearly always comes out in the region of 30 to 50. So if you ask me, Paul, how often do you do this calculation? Specify the width, do the maths, calculate the sample size. I rarely do it. I tend to use a simple guideline, which is that if I've got measurable data, I'm going to take a sample size somewhere between 30 to 50. What that does is make my confidence intervals nice and tight. What do tight confidence intervals tell you? I got a good estimate. That is why you need confidence intervals, to tell you how good your estimate is, and to make sure you always use a great sample size. If you always use a great sample size, you always get good estimates, and therefore your decision making, your decisions are going to be so much better if you're making them from a great estimate. Understand confidence intervals, get great sample sizes, make more intelligent, better business decisions. Confidence intervals. If you'd like to know more about any of the concepts covered in this video, or any of the other concepts covered in my other tutorial videos, then here's my latest book, Drink Tea and Read the Paper. Covers everything you need to know about how to make sure that Six Sigma becomes world-class engineering in your company. Otherwise, if you'd like to get in touch with me, a little bit of help about Lean, a little bit of help with Six Sigma, please contact me on the email below.